The cockpit voice recorder captured their final words with chilling clarity. Hydraulic pressure dropping. Switching to backup system. First Officer James Chen calmly reported. Captain Michael Rodriguez acknowledged with steady professionalism. Roger that. Running emergency checklist. What happened in the next 97 seconds would defy explanation and challenge our fundamental understanding of aviation safety. By all measures, the crew of UPS Flight 2976 did everything right. Every decision, every action, every response followed textbook procedures. Yet on April 29, 2023, their Boeing 747-8F cargo jet slammed into an industrial zone just 3 miles short of Louisville's runway 17R, killing all 4 crew members instantly. How could a catastrophic failure occur when the pilots made no mistakes? The answer would uncover troubling questions about the systems we trust to keep us safe in the skies. The initial news reports portrayed it as just another unfortunate aviation accident. Early morning headlines described a UPS cargo plane crash near Louisville Airport, with the typical speculation about pilot error or extreme weather. But as investigators from the National Transportation Safety Board arrived on scene, they discovered something far more disturbing. The wreckage told a story that didn't align with typical accident patterns. The aircraft hadn't stalled. It hadn't run out of fuel. The weather was clear with light winds. And most importantly, the flight crew, with over 45 Uhr-Zeren combined hours of experience, had executed perfect emergency procedures right until impact. The aircraft, a 6-year-old Boeing 747-8F registered as N624 UP, had departed Miami International Airport at 9:47 p.m. Eastern, and carrying primarily mail and packages on its routine overnight run to UPS's main air hub in Louisville. The first 3 hours and 41 minutes of flight were completely normal. Air traffic control recordings reveal standard communications, routine clearances, and no indication of any mechanical issues. The crew reported they were established on final approach at 11:28 p.m. 7 minutes later, they were dead. What happened in those 7 minutes has become the focus of one of the most intensive NTSB investigations in recent history. Let's step back and understand what makes this case so exceptional. Commercial aviation has achieved remarkable safety records by implementing multiple redundant systems. The Boeing 747-8F specifically has 3 separate hydraulic systems, primary, secondary and standby, each capable of maintaining critical flight controls independently. The statistical probability of all 3 systems failing simultaneously has been calculated at less than 1 in a billion flight hours. Yet that's exactly what happened to Flight 2976. It was the aviation equivalent of being struck by lightning while winning the lottery during a solar eclipse. Radar data shows the aircraft's descent profile was textbook perfect until approximately 800 feet above ground level. At that point, the plane suddenly pitched downward at a 30-degree angle, an uncommanded movement that the pilots fought desperately to correct. According to the flight data recorder, they responded instantly, applying full back pressure on the control column and maximum engine thrust, exactly what the emergency procedures call for. Their reaction time was exceptional, less than 3 seconds from pitch anomaly to full countermeasures. In any normal circumstance, this should have been enough to recover, but Flight 2976 continued its deadly plunge. What makes this accident particularly haunting is the recovered cockpit voice recording. Unlike many aviation disasters where panic ensues, the UPS crew maintained remarkable composure throughout the emergency. After identifying the initial hydraulic pressure drop, they methodically worked through the appropriate checklists. When the secondary system also began showing pressure fluctuations, you can hear them calmly transitioning to the standby system. There's no shouting, no confusion, no deviation from protocol. Captain Rodriguez is heard coaching his first officer. "You've got this, James. Standard procedure. We've trained for this. Even in the final seconds, as the aircraft became unresponsive to their inputs, their professionalism never wavered. The last recorded words were Rodriguez saying, "Max power, nose up, standby system engaged," followed by Chen confirming, "All recovery actions complete." 7 seconds later, impact. The crash site itself provided crucial early clues. The Boeing 747-8F hit at a steep angle but relatively low forward speed, creating a compact debris field rather than the long scatter pattern typical of high-velocity impacts. This suggested the aircraft maintained some level of control until the end. The pilots were fighting the anomaly, not completely helpless. The wreckage revealed no signs of in-flight fire or structural failure before impact. Most tellingly, when investigators recovered the hydraulic system's components, they discovered something unprecedented: evidence of near-simultaneous failure in all 3 independent systems. Initial speculation focused on possible sabotage or an extraordinarily unlikely coincidence of separate failures. But as the NTSB dug deeper into the maintenance records and component manufacturing history, a more troubling picture emerged. The hydraulic pressure control valves installed in N624 UP came from a single manufacturing batch produced in October 2022 by a third-party supplier. These valves, critical components that regulate hydraulic pressure throughout the aircraft, had passed all standard quality control tests. Yet metallurgical analysis revealed microscopic stress fractures in the valve housings, defects invisible to routine inspection methods. In normal operation, these fractures wouldn't pose an immediate threat. But the NTSB investigation uncovered that this particular batch of valves had a manufacturing anomaly: microscopic hydrogen embrittlement in the metal alloy, a condition that can cause progressive weakening under the normal stresses of flight. Even more concerning, internal documents obtained during the investigation suggested that quality control engineers at the supplier had flagged potential issues with this production batch, but those concerns never triggered a formal safety alert or recall. The tragedy of UPS Flight 2976 exposes a frightening vulnerability in our aviation safety system. The crew did everything right. The maintenance team followed all prescribed procedures. The aircraft passed every required inspection, yet 4 people still lost their lives because of nearly invisible defects in critical components, defects that slipped through multiple layers of quality control. This wasn't a case of human error or procedural failure by the flight crew. It was a systemic breakdown in how we manufacture, inspect, and monitor the complex machines we trust with our lives. For the families of Captain Michael Rodriguez, First Officer James Chen, Flight Engineer Sarah Thompson, and Loadmaster David Miller, the NTSB's findings offer a bitter confirmation. Their loved ones were consummate professionals who performed flawlessly under impossible circumstances. As Miller's daughter told reporters, "My father spent 27 years making sure planes were safe. He died doing everything right." The cruel irony is that this crew's perfect performance in the face of catastrophic failure has exposed critical weaknesses that might otherwise have remained hidden until causing even more tragedy. If you fly regularly or have packages delivered by air, this case matters to you. The NTSB's final report, expected next month, will likely recommend sweeping changes to how critical components are manufactured, tested, and monitored throughout their service life. Share this video with anyone who cares about aviation safety. In our next segment, we'll examine exactly how these hydraulic failures cascaded, what the flight crew experienced in those final moments, and the specific changes already being implemented across the aviation industry. The story of UPS Flight 2976 isn't just about what went wrong. It's about redefining what we mean by safe enough in modern aviation. To understand the full significance of what happened to UPS Flight 2976, we need to examine how hydraulic systems function on modern aircraft. Think of hydraulics as the muscles of an airplane. While the pilots issue commands, it's these pressurized fluid systems that actually move the control surfaces, the ailerons, elevators, and rudders that determine an aircraft's attitude and direction. On a Boeing 747-8F, hydraulic systems operate at around 300 psi, generating forces powerful enough to move massive control surfaces even against the extreme aerodynamic pressures experienced during flight. Boeing designed the 747 with three completely independent hydraulic systems, designated primary, secondary, and standby. This triple redundancy means that even if two systems fail completely, the third should provide enough control authority for a safe landing. Each system has its own reservoirs, pumps, filters, and lines, with no shared components that could create a common point of failure. This design philosophy has proven remarkably effective. Prior to Flight 2976, there had never been a documented case of all three systems failing simultaneously on any 747 variant in over 50 years of operation. The NTSB investigation revealed that at 11:31 p.m., approximately 4 minutes before the scheduled landing time, sensors detected a pressure anomaly in the primary hydraulic system. The defective pressure control valve had begun to fail, allowing pressure to drop below operational minimums. Following standard procedure, the system automatically isolated the failing component and switched critical functions to the secondary hydraulic system. Captain Rodriguez and Flight Engineer Thompson acknowledged the alert and began running the appropriate checklist. This type of single-system failure is something crews train for routinely, and at this point, there was absolutely no indication of serious danger. 37 seconds later, however, the secondary system began showing identical symptoms. This was already an extraordinarily rare coincidence, but still within the aircraft's design parameters. The crew immediately initiated the dual hydraulic failure procedure, transferring essential control functions to the standby system. Their actions were quick, precise, and by the book. Voice recordings reveal no alarm or panic, just focused professionalism as they worked the problem. As Captain Rodriguez noted to his crew, "Standby system is operational. We have control authority. Standard approach. Just be ready for heavier controls." Ready. What happened next defies the fundamental safety assumptions of modern aviation. Just 23 seconds after the secondary system failure, the standby system began showing pressure fluctuations as its valve, from the same faulty manufacturing batch, succumbed to the same failure mode. This was the scenario that Boeing engineers had deemed statistically impossible. Even in this critical situation, the UPS crew's performance was exemplary. The flight data recorder shows them immediately applying emergency procedures for total hydraulic failure, attempting to use differential engine thrust and the limited remaining hydraulic pressure to maintain control. For 42 agonizing seconds, they nearly succeeded. The aircraft responded sluggishly, but remained controllable as they lined up with runway 17R. Louisville Air Traffic Control, now aware of the emergency, had cleared all traffic and dispatched emergency vehicles. Had the failure sequence stopped there, this might have become a case study in successful emergency management rather than a tragedy. But as the aircraft descended through 800 feet, the standby system's pressure dropped below the minimum threshold needed for flight control authority. The plane pitched downward abruptly, no longer responding adequately to the pilot's inputs. Despite applying full corrective measures, maximum back pressure on the control column, and full engine power, the aircraft continued its fatal descent. The failure sequence that doomed Flight 2976 reveals a troubling gap in how we certify aircraft components. The pressure control valves that failed had passed all required inspections and tests. The hydrogen embrittlement that weakened the metal was undetectable by standard quality control measures. Most concerning, the NTSB investigation found internal emails at the valve manufacturer acknowledging that this production batch had experienced anomalous readings during final testing, but these readings fell within acceptable limits and thus didn't trigger a rejection. What we're facing here is not a failure of procedure or human error, but a failure of imagination. The certification standards were built around preventing known failure modes. No one had anticipated this particular defect because it had never been observed before. The probability calculations assumed that failures in redundant systems would be independent events. No one considered that components manufactured in the same batch might share hidden defects that could manifest simultaneously under similar conditions. Comment below with your thoughts on how we should balance the practical realities of manufacturing with the absolute demands of aviation safety. In our next segment, we'll examine the human side of this tragedy, the 4 crew members who did everything right but still lost their lives, and the families left searching for answers in the aftermath of an impossible accident. The human cost of UPS Flight 2976 extends far beyond the crash site in Louisville. Behind each name on the manifest was a life rich with connections, achievements, and unrealized potential. Captain Michael Rodriguez, 58, was just 6 months from retirement after a 34-year career in aviation. Colleagues described him as a natural teacher who mentored dozens of younger pilots. His wife Maria told investigators, "Mike checked and double-checked everything. If there was a procedure, he followed it to the letter." This meticulous attention to detail was evident in the cockpit voice recordings. Rodriguez methodically worked through emergency procedures even as the situation deteriorated rapidly. First Officer James Chen, 42, had joined UPS 8 years earlier after serving as a C-17 transport pilot in the Air Force. He was known for his exceptional technical skills and calm demeanor under pressure. Both qualities were on display during those final minutes. Flight engineer Sarah Thompson, 35, was one of the few women in her position at UPS and had recently completed her private pilot's license with hopes of eventually moving to the cockpit. Loadmaster David Miller, 49, a 27-year UPS veteran, left behind 3 children and a reputation as the company's most knowledgeable expert on hazardous cargo handling procedures. What makes this tragedy particularly wrenching is that their deaths weren't the result of any mistake or negligence on their part. As Miller's daughter explained through tears at a memorial service, they were betrayed by the systems they trusted. This sentiment has become central to how aviation experts are viewing the case. These 4 professionals had done everything their training prepared them to do, executed every procedure correctly, and still could not prevent disaster. This reality has profound implications for how we think about aviation safety. The NTSB investigation has uncovered disturbing details about the manufacturing process for the failed hydraulic components. The pressure control valves came from a production batch made at a facility in Arizona that had recently changed ownership. During this transition period, the facility had implemented new, automated quality control procedures that, while meeting all certification requirements, actually performed fewer types of metallurgical tests than the previous manual inspection protocol. The microscopic hydrogen embrittlement, essentially tiny bubbles of hydrogen gas trapped in the metal during manufacture, wasn't detected because the new testing protocol wasn't designed to look for it. Perhaps most troubling, NTSB investigators discovered emails between quality control engineers discussing anomalous readings from this batch. One engineer wrote, "Values are within tolerance, but showing unusual patterns, probably nothing, but might be worth additional testing. This recommendation for extra scrutiny was declined by management, who noted that all parameters meet certification requirements and that additional testing would delay shipment to Boeing. This decision, while technically compliant with all regulatory requirements, highlights a dangerous grey area in aviation safety, the gap between minimum compliance and maximum safety. Boeing, for its part, had no reason to suspect issues with these components. The manufacturer was a long-standing approved supplier with a good track record. The certification paperwork was complete and showed all tests within acceptable parameters. Boeing's incoming quality control focused primarily on dimensions, fit, and function, not repeating metallurgical tests that had supposedly been completed at the supplier. This multi-layered system of delegated responsibility is standard across the aerospace industry, but the UPS 2976 disaster exposes its vulnerability to cascading failures when initial quality control misses critical defects. Since the accident, both Boeing and UPS have implemented additional safeguards. UPS has begun requiring that critical components for each of its redundant systems come from different manufacturing batches, a simple but effective way to reduce common mode failures. Boeing has added new testing requirements specifically designed to detect hydrogen embrittlement in hydraulic components. The FAA is currently reviewing certification standards for critical flight components, with proposed revisions expected to be released for public comment next month. But these changes come too late for the families of Flight 2976's crew. In a particularly poignant detail, investigators found Captain Rodriguez's retirement paperwork in his flight bag at the crash site. He had planned to submit it upon landing in Louisville, marking the beginning of his final 6 months with the company. First Officer Chen's iPad contained photos of his daughter's 5th birthday party from the previous day. Flight engineer Thompson had texted her fiancé just before takeoff. "Routine overnight to Louisville. See you for breakfast tomorrow. Let me know in the comments if you think commercial aviation has become too reliant on automated testing and computer modeling rather than hands-on inspection by experienced technicians." In our next segment, we'll examine the forensic investigation in detail, how NTSB engineers pieced together the complex failure sequence through microscopic analysis of the wreckage, and the surprising discovery that might prevent similar tragedies in the future. The investigation into UPS Flight 2976 represents one of the most complex forensic puzzles the NTSB has ever undertaken. Unlike many aviation disasters where the cause is quickly apparent, this case required investigators to work backward from an impossible event, the simultaneous failure of 3 redundant systems. Lead investigator Dr. Jennifer Malone described it as looking for a needle in a haystack, except we didn't even know what kind of needle we were searching for. The breakthrough came 3 weeks into the investigation, when metallurgist Dr. Robert Kang noticed something unusual while examining fragments of the failed pressure control valves under an electron microscope. The metal showed distinctive patterns of intergranular fracturing, a telltale sign of hydrogen embrittlement. This condition occurs when hydrogen atoms infiltrate metal during manufacturing, making it brittle and susceptible to failure under stress. What made this case extraordinary was finding identical degradation patterns in components from all 3 hydraulic systems. Dr. Kang's discovery prompted a deeper investigation into the manufacturing process. The valves came from production lot WJC 2378, manufactured in October 2022 by Aerotech Precision, a third-tier supplier to Boeing. NTSB investigators learned that just before this batch was produced, Aerotech had modified their manufacturing process to improve efficiency. They had changed the chemical bath used in the metal finishing process, switching to a solution that was more environmentally friendly, but also created higher risk for hydrogen infiltration if not precisely controlled. Internal quality control documents revealed something even more disturbing. Aerotech's routine testing had actually detected unusual metallic structure in samples from this batch, but the readings fell within the broadest interpretation of acceptable parameters. Rather than conducting additional testing, the quality manager, under pressure to meet delivery deadlines, approved the batch for shipment. As one Aerotech employee told investigators off the record, "We were running 3 weeks behind schedule and had Boeing breathing down our necks. The parts met minimum specs, so they went out." This decision illuminates a dangerous gray area in aviation manufacturing. The parts weren't technically defective according to existing certification standards. They met all the minimum requirements on paper, but they clearly lacked the safety margin that redundant systems are supposed to provide. The accident has prompted renewed debate about whether current testing protocols are sufficient for components used in critical redundant systems. The NTSB's forensic analysis also revealed why the failures occurred in such rapid succession during this specific flight. The 3 valves had been operating normally for 6 months before the accident. What changed on April 29th? The flight data recorder provided the answer: unusual atmospheric conditions. That evening, the aircraft passed through an area of exceptional turbulence at 32,000 feet, approximately 45 minutes before beginning its descent into Louisville. This turbulence created a specific vibrational frequency that resonated with the weakened metal structures in the valves. Think of it like an opera singer shattering a crystal glass by hitting just the right note. The turbulence sang at exactly the frequency that stressed the already compromised valves. This vibration wasn't severe enough to damage properly manufactured components. But for these weakened parts, it started microscopic cracks that grew rapidly under pressure. The primary system failed first, simply because its valve was positioned in an area of the aircraft that experienced slightly more vibration. The secondary and standby systems failed soon after as their valves, weakened in exactly the same way during manufacture, succumbed to the same stress patterns. What makes this scenario so frightening is its implications for redundant safety systems throughout aviation. The entire concept of redundancy assumes that backup systems fail independently, not all at once from a common cause. If components that appear identical can share hidden defects, the mathematical models we use to calculate failure probabilities become fundamentally flawed. In response to these findings, the FAA issued an emergency airworthiness directive requiring inspection of all hydraulic pressure control valves from the suspect manufacturing batch. To date, airlines and cargo operators have removed 342 potentially affected valves from service. Boeing has implemented new requirements that critical components for redundant systems must come from different manufacturing batches and, ideally, different suppliers. The company has also added new testing protocols specifically designed to detect hydrogen embrittlement. The most profound change, however, may be philosophical. The aviation industry has long relied on a probabilistic approach to safety, calculating the odds of component failures and designing systems to achieve acceptable risk levels. The UPS 2976 accident challenges this foundation by demonstrating that supposedly independent systems can share hidden vulnerabilities, making mathematical risk models dangerously optimistic. Where do you think the balance should be between efficiency and redundant safety in aviation? Tell me in the comments below. In our final segment, we'll examine the lasting impact of this accident on aviation safety culture, the legal and regulatory aftermath, and the memorial that UPS employees have created to honor colleagues who did everything right and still couldn't prevent disaster. Odrads, in the aviation community, there's a sacred trust between those who build aircraft, those who maintain them, and those who fly them. Each group depends absolutely on the others doing their jobs with unwavering precision. The tragedy of UPS Flight 2976 has shaken this trust to its core, when pilots, following every procedure perfectly, still lose their lives due to a manufacturing defect that slipped through quality control. It forces a fundamental re-evaluation of the systems we've built to ensure safety. The legal aftermath has been swift and far-reaching. The families of all 4 crew members filed wrongful death lawsuits against Aerotech Precision, the valve manufacturer. Unlike many such cases that drag on for years, these were settled within months, a tacit acknowledgement of clear liability. The undisclosed settlement amounts are rumored to be among the largest in aviation history, reflecting not just the loss of life, but the egregious nature of the quality control failures that led to the accident. Boeing, while not named as a defendant in these lawsuits, has implemented what insiders describe as the most comprehensive supplier review in company history. Every component provider is undergoing enhanced scrutiny, with particular attention to those supplying parts for redundant safety systems. The company has also revised its design philosophy for future aircraft, moving toward what engineers call diverse redundancy, ensuring that backup systems not only operate independently, but are fundamentally different in design and manufacture to eliminate common failure modes. The regulatory response has been equally significant. The FAA has issued new certification requirements for critical flight components, including mandatory testing for hydrogen embrittlement and other microscopic material defects. Perhaps more importantly, they've revised the mathematical models used to calculate failure probabilities, now requiring manufacturers to account for the possibility of common mode failures in supposedly redundant systems. As one FAA official put it off the record, "We've been calculating 1 in a billion failure probabilities based on the assumption that redundant systems fail independently." UPS 2976 proved that assumption dangerously wrong. UPS has honored its fallen crew members with a permanent memorial at its Louisville hub, 4 granite pillars surrounding a central sculpture of a 747 ascending into clouds. The inscription reads simply, "They did everything right. We fly on to make it right for them." The company has established scholarships in each crew member's name and implemented what it calls the 2976 protocol, additional inspections specifically focused on components that could experience common mode failures. Perhaps the most powerful tribute, however, comes from the day-to-day practices of the aviation professionals most affected by this tragedy. UPS pilots report a new ritual during pre-flight inspections. After completing the required checklist, many touch the aircraft's hydraulic access panel and quietly say, "For Mike, James, Sarah, and David." And Dido. It's a small gesture that acknowledges both the tragedy of Flight 2976 and the renewed commitment to vigilance it has inspired. The psychological impact on the industry has been profound. There was something uniquely terrifying about this accident for those of us who fly, explains Captain Sandra Williams, an A320 pilot for American Airlines. "We're trained to believe that if we do everything right, if we follow procedures perfectly, we'll get the plane down safely even when things go wrong. The UPS crew did everything right, and they still died. That shakes your foundational beliefs as a pilot." This case has also sparked renewed debate about automation and human oversight in aviation. While computerized testing and manufacturing have brought remarkable precision and efficiency, the Aerotech quality control failure highlights the dangers of removing experienced human judgment from the loop. The quality control engineer who noticed unusual patterns in the test data but was overruled by management might have prevented this tragedy if empowered to demand additional testing. As a result, many manufacturers are now re-evaluating their balance of automated and human quality control processes. For the aviation industry, the legacy of UPS Flight 2976 will likely be a fundamental shift in how we think about safety margins and redundancy. The old approach assumed that meeting minimum specifications with redundant systems was sufficient. The new paradigm emerging post-accident recognizes that true safety requires components to substantially exceed minimum requirements, especially in critical applications where lives depend on reliability. When Captain Rodriguez and his crew began their descent into Louisville that April night, they trusted completely in the systems they'd been trained to operate. They had no way of knowing that microscopic flaws, invisible to standard inspections, had compromised the redundancies designed to protect them. Their tragedy has exposed vulnerabilities that might otherwise have remained hidden until causing even greater loss of life. As we conclude this investigation, I ask you to remember not just what went wrong, but what went right on UPS Flight 2976. Remember a flight crew that performed flawlessly until the very end. Remember engineers and investigators who refused to accept impossible failures and instead dug deeper to find the truth. And remember that every safety protocol in aviation is written in the ink of lessons learned, often at terrible cost. The next time you see a cargo plane crossing the night sky, spare a thought for the professionals in the cockpit and for Mike, James, Sarah, and David, whose final perfect performance in an impossible situation has made aviation safer for everyone. Share this video with someone who works in a safety-critical field. The lessons of UPS Flight 2976 extend far beyond aviation to any industry where redundant systems are relied upon to prevent disaster. Because sometimes doing everything right isn't enough. We also need systems designed to make failure truly impossible.